We come now with the last talk, which is on the left brachiocephalic or innominate vein. Giulini, at one of these last meetings, she asked me, but this is something so, what did you say? So simple, so obvious that you sit and you do a study on something we see every day. But I have to tell you, I'm receiving often emails or with images. What is this vessel? I see something abnormal going there and so on. Why? Simply because most of you now have understood the four-chamber view, have understood how to get to the three-vessel view. They are looking to the thymus, and occasionally they see something there, something which, especially on color Doppler, is so impressive that they don't see. This is why they may see something where they didn't expect to see color, and they are asking if this is something normal or abnormal. The learning objective of this talk is to understand the anatomy of this region, and why is it called the left brachiocephalic vein. I don't like innominate vein personally because it says this is the name of the vein is the vein without a name. Innominate means without name, which does not make a sense. The same like the artery. We should recognize the typical suspicious finding, and I think you should think about using this in screening. Now, interestingly, when I was writing the book with Alfred Abu Hamad, we cite at the page where it was written that the dilated brachiocephalic vein could be a sign of supracardiac venous drainage. We were saying, what is dilated? If we don't have values, we can't tell it's dilated. It's more your impression. And we said we should do something. And I started with Catherine Carl to do some measurements. And they had, in the meantime, also begun. And then we put our data together. We analyzed 370 fetuses between 11 and 14 weeks. And I will recall with you a few data. This is a nice drawing I found in this article of Bennett and co-workers on thoracic surgical clinics. And look at the anatomy we are speaking about. First of all, we know the superior vena cava. The superior vena cava is not coursing from the neck to the heart. It's only this lower part. And if you look at the venous system, we have the jugular vein in the neck region. We have the subclavian veins. I showed you one in my talk on subclavian artery. And when they merge together, this part then is called the left brachiocephalic vein, and this one is the right brachiocephalic vein. The right brachiocephalic vein is a little bit difficult to identify because it's in a way continuous between these and the superior vena cava. But the left brachiocephalic, when it's merged with the right brachiocephalic, builds the superior vena cava. This is why this vessel is, in a way, such long and horizontal that we can see it easily just in front of the three-vessel view. Now, once we scan at the level of the upper thorax, what we see today in the upper mediastinum, we see the three-vessel trachea view. We see in front of this vessel the thymus. And if you move a little bit upward and you get a slightly oblique view, then you see just behind the thymus as dividing the thymus from we left the three-vessel view. We see the three brachiocephalic artery. We see such a vessel with the course from the left to the right. This is why you know what is the color Doppler going to show. Now, this was done also by the group of Alfred, where you see here a cut in the upper thorax, and you see this vein just behind the thymus at the level where the three vessels are there, and you see here exactly the scheme I was showing you before with the left brachiocephalic vein. Now, how can we see it? You go to the four-chamber view, you move to the three-vessel view, and you move a little bit higher, and then you see this vessel anterior to this one. And this is where we measured in the middle, as things are usually measured. And on color Doppler, it is fantastic because you can see the red color going to the right shoulder. And if you stop at the right moment, you see that the three vessels are the brachiocephalic artery, the trachea, and the left common carotid and the right common carotid. Now, you can also see it in a longitudinal view. I wanted to put this in a kind of quiz at the beginning, but because it's anterior to the vessels, you see it is there. But in general, we don't point to this part because we are focusing on the aortic arc and these vessels and on the right pulmonary artery. So now we measured the values between 11 and 40 weeks, and you for, let's say, under normal conditions, I prefer easy signs and formulas. And I observed that, roughly speaking, the value was nearly gestational age divided by 10. That means at 20 weeks, it should be around 2, and at 30 weeks, it was around 3 millimeters, and this is actually enough, because the values which are abnormal when they are dilated, they are so large that you can't even measure it during gestation. That means, roughly speaking, you don't need to go to the curve. You may need to publish something if you want to plot it, but if you want a rule of thumb, go for, take a 0 away, and then you have, add a 0, and you have gestational age. Now, one of the things I've seen many years before, and let's say the 3-4 I've seen at the beginning, I've done invasive to rule out macrodeletion 22q11, we saw what was not yet described, because in pediatric it doesn't play any role, and even later on, an intrathymic course of this vessel. And this is a common cause. You want to make a photo? Please go ahead. Okay. So the intrathymic cause, what we saw is that when we see these vessels, we have thymus, then we have the vessel, and then we have thymus again. And this is something which is actually very common. I can't tell you it's 1%, but it's something like 1 out of 200 cases. That means if you scan every day, you see occasionally such a vessel. We have seen a couple of them. Few of them we have done invasive. There was never additional things, and this is why it's a norm variant. I don't mention it anymore. But you should know that these cases are there, especially when you look at this region more carefully. The most interesting part is the dilated vein. It can be present in roughly 3 conditions. The first one, and the most important one for us, is when you have supracardiac abnormal lung vein connection. That means you have the whole lung, the left and the right, are draining into the vertical vein, and then they go into the brachiocephalic vein, and they lead to its dilation, because under normal conditions, you have the half of the brain draining into this vessel, and then the left arm, and then in addition you have both lungs, and this leads to a huge dilation of this vessel. And of course in vein of Galen aneurysm, but most of you will not look at it because you are so impressed by the brain finding and by the heart dilation that you don't see it. But it's logical. If you have a lot of flow in the brain and you have a cardiac dilation, blood should arrive to the heart, and it comes via the dilated superior vena cava and via the dilated upper vein system. And as Kai said before, in hypoxia and centralization, it can be found, but not so impressive that you can see it. In general, you are more impressed by the echogenic bowel, by the anhydramnio, by centralization, by coronary arteries, and not by the brachiocephalic vein. So this is here a nice clip done by Jean-Philippe Gentil for our Part 2 DVD, where you see that blood comes from both lungs, goes into the upper vessel, and then lead to the dilation of the brachiocephalic vein. And this is what we see under normal conditions. You see here a longitudinal approach, the pulmonary vein, and this here is the dilated vessel, dilated brachiocephalic vein in the upper thorax. Now, on angio, this is what we see here. And it is well seen as a dilated vessel. And this is what we put in our book at that time. It was so impressive to see this image, and we said, well, this is such a typical sign. And now you see the connection between both dogs. If you see in the fourth chamber view something behind the heart, and you say, well, it could be supracardiac, which is the common one, go to the upper thorax and see if you have dilated left brachiocephalic vein. And the combination of both could be a typical hint for your first or your second supracardiac abnormality. So now, well, if you want to complete the collection, you see the normal condition and the dilated vein. You are impressed what is this black dot. This is the dilated vein, and you see the thymus in front of the aorta. And you see in vein of Galen aneurysm, I cannot tell you that there is any difference to the other case. They look similar. They have also on our value similar values here, and you see compared to the normal cases. Only some cases they have normal value. I will show you then at the end. Now, occasionally, this vessel is also absent. When can be absent? In the presence of bilateral superior vena cava. I never saw this bridging vein in bilateral superior vena cava, but Jim Huta told me, you have to read the literature. In one of my papers, I described many cases, but in the 80s, he used to see in half of the cases it was absent, but in all cases I saw, if it's bilateral, I never saw bridging vein. I don't know what he was seeing in the 80s. Probably if he would have color Doppler, he may have seen other things, but we probably need an additional study. But in the 60 cases we had in this paper, we didn't find anyone. And what you see here is superior vena cava, aorta, pulmonary trunk, and left superior vena cava. And by going with 2D to the upper thorax, you see the thymus and you don't see any connecting vein. Do you see here the absence of, yeah. No, because you have a left superior vena cava draining into the coronary sinus, you have a right superior vena cava or right jugular vein going to the heart. And in order to understand, and you see here in longitudinal view, there is no vessel here. In order to understand this, let's go back to the embryology, and there is an explanation for this. Now, this is a little bit difficult to understand, but focus for a minute on it. This here is the primitive heart. We are looking to the heart from behind. Here we have umbilical vein, vitelline vein, and cardinal veins, and these are going to build the liver and IVC, inferior vena cava, and so on. This is the right side. This is the left jugular vein, and this is the brachiocephalic vein. And we have, in very early embryonic time, a left superior vena cava and a right superior vena cava. And this is here what Philippe Gentil did. This is a video clip on what happens under normal conditions. We have a left superior and a right superior vena cava. There is the development of the bridging vein, of the brachiocephalic vein, and then blood will preferentially go this way, and this will disappear. Occasionally, you see in some pathologic book some ligamentum called the ligamentum of Marshall, which is present here. This is the normal condition. The embryological background of a left superior vena cava is that this bridging vein will not connect, and you still have a persistence of left superior vena cava, leading to the dilation of the coronary sinus. If you find here and there, it is likely to have an abnormal lung vein drainage going to the upper part and leading to its drainage. Exception, if you have a left superior vena cava, but no and the absence of the right superior vena cava. Then we have the opposite. That means we have the right jugular vein, and this is here tricky because this is trachea, aorta, pulmonary trunk, left superior vena cava. There is no right superior vena cava. That means we have the right arm vein and the jugular vein. They will drain across a right brachiocephalic vein, what you see here. This is why if you find the left superior vena cava with the bridging vein, this is the right brachiocephalic vein crossing over. So I don't want to make things very complicated. In summary, we can say that the left brachiocephalic vein can be easily visualized in a plane a little bit higher than the three-vessel trachea view behind the thymus. Its diameter is between 2 to 4.5 millimeters, and as I told you, it is roughly gestation age divided by 10. There is some common variant, which is instead of being behind, it is across the thymus, not being straight, but having kind of bend structure. It's a norm variant without need to being sighted. It is dilated in high flow either due to lung abnormalities in terms of supracardiac abnormal vein drainage, or to Galen or any other cranial arteriovenous fistula. And it is absent in the presence of bilateral superior vena cava. I hope this new sign can help you in your everyday work, and I thank you for your attention.